Hello there, Prof here. Welcome to C++ 101. This is the fourth episode, and in this episode I'm going to discuss in details the character data type. Now, if you haven't watched my previous tutorials, then please do so now, because this is a continuation from the previous episode. Okay, let's get started. In the previous episode, we talked about the various fundamental data types. We also said that data types contain information about the size of memory space to allocate and the kind of operation that can be performed on the data. Now, let's take a second look at the character data type. A character data type, or a character, is a 1-byte integer. However, it is typically represented in its ASCII form. Character data types are delimited by single quote. So let's take a look at this piece of code. So in this code, if you look at line 5, 6, and 7, I've created 3 variables: gender 1, gender 3, gender 4. Okay. Now, gender 1 is obviously an error. It's going to give us an error because the moment you delimit a letter or a character by double quotes, it means that you are making it a string literal. Okay, and if you look at the string data type, they are way different from the character data type. So if we run this code right now, we should get a compile time error, which says that invalid conversion from const char to char. So the right way to assign value to a character variable is by putting your character data inside a single quote. Now, if you happen to put a sequence of characters, as I've done here, inside a single quote, what is going to happen is that the compiler will throw a warning. However, it will try to remedy the situation by picking the last letter or character in the sequence of characters. So let's comment out line 5 and take a look at how this works. So over here, you could see that we have gender 3M and gender 4E, and you could see that this E is coming from male. Okay, the E in male. So it means that C++ skipped over the capital M, small a, L, and it took only the E. Now, if you think I'm making this up, let's change this one to, let's say, a hash sign, and run the program again. And again, realize that the gender 4 is assigned the hash value. Okay, so that is what happens when you try to put a sequence or a string inside a single quote and assign it to a character variable. And you can see down here the warning that the compiler is giving. The first one says that character constant too long for its type, and the second one says overflow in implicit constant conversion. So whatever that means, in simple and short, it means that you are not doing something right. Now, the moment I comment this out and also take this out and run this, you realize that we are not going to get those errors, and that means that everything is working as it is supposed to be. Okay, sometimes it is easy to get confused about a digit as a number and a digit as a character. Okay, now what do I mean? So over here I've created an integer variable num1, and I've set it to the number 8. Now let me change this to num2, and here I've set it to the character 8. Now, why is this character 8? It's simply because it is inside a single quote. Now, the next thing I'm doing is multiplying each of these variables by the number 3. So let's look at the results. Oh, sorry, I forgot to change this one to 2. Okay, so let me run it again. Alright, so in the first case, where we used int and set the number to 8, okay, we actually got 24, and obviously you can see that it is coming from 24 times 8 times 3, which is 24. But then why are we getting 168 in this case? Okay, now because here we are dealing with a character, what C++ is doing is performing this multiplication using their ASCII value. Now, if this would make you understand, let me also change this data type to int. Now, because characters are by nature integer values, this is actually allowed in C++. So what I've done is I've created an integer variable and I'm assigning a character value to it. Now let's look at the results. So you can see that still we are getting 24 and 168. Now what is happening here is that because here the number 8 is inside the character, it is no more the number 8 but is the character 8. And the ASCII value for the character 8 is 56. So if you multiply 56 by 3, then you get the 128 that was displayed on the screen. So you can go ahead and test this for other characters and verify things for yourself. C++ also allows you to assign the ASCII value or the base 10 representation of the characters to the character variables. So for instance here I have a character variable num1 and I'm setting it to 65. Now what is going to happen is that C++ is going to rather save the representation of this 65, which is ASCII capital A in num1. So if we run this program, we should rather see num1. We should rather see capital letter A instead of 65, as you can see over here. Inversely, you can also set a character variable to an integer variable, as we did in the example here. So here what will happen is that C++ automatically converts this ASCII letter A to its ASCII value, which in this case is going to be 65. So when we print this out, instead of capital A, we are going to get 65. This is because num1 is by default an integer. So the program will try to give us num1 in its integer representation. Num2, and that is 65. There are some special characters called escape sequences which when used in code has special meaning. Now this table shows some of these characters. So the first one is carriage return, which is /r. Now when you use this in code, what happens is that it moves to the beginning of the line. Now for some of these, I'm going to try my best to demonstrate them in code. So just listen to the explanation, you will see them in work. So we also have /t for a tab, /v for vertical tab, /single quote, /double quote, // which is when you want to print a backslash, /question mark when you want to print a question mark. Now you later find out that most of these are actually not working as it's supposed to be, but the few that actually works, I'm going to demonstrate it. Then there is a way to represent an octal number, a base 8 number, and the way you do that is by a backslash followed by the number you want to represent, but this number has to be in the base 8 format. Equivalently, you can also do the same for base 16, and for the base 16, what you do is you start with a backslash and x followed by the number in the base 16. So let's quickly look at this in code. Let's start with the alert. So what I have here is a simple CL statement that says /a hello world /a. Now listen carefully, you should hear a sound. Now the sound that it produces will be the default beep sound on the system you are using. So that was the sound. Okay, so the computer or C++ interpreted this /a as a special character, which in this case it's made the computer play its default sound. So we call it the alert. The next one is the backspace. So I have a cout statement here that says that cout prof/b say. Okay. Now the way a backspace work is, it deletes the character, the next character to the left of the current cursor position. So this is what is going to happen. It will print PROFES. Then it will come across this backspace, which will instruct it to delete the letter to the left, which in this case is S. Then it will continue and print out the se. So instead of professor with double S, you are going to get professor with a single S. Alright, so that is it. So you can see that we have just one S instead of two. The next one is the Newline character, which is /n. Now you realize that mostly when we perform cout statement, we put the n line at the end. What the n line does is take the insertion point to the next line. Okay. However, we can do it in another way by using /n. And take note, in this case, the /n is within the string. Okay, the /n is within the string. And when we do this, it will have the same effect like putting the /n at the end. So let's take a look at it. So you can see hello world, and the next one was printed on the next line. Okay, so let's look at the code. So here we have hello world followed by a backslash, and this backslash told it to take it to the next line. Now, in case you don't believe what I'm saying, let's delete this line and see what happens next. So we get hello world hello. Okay, because we never instructed the computer to take the insertion point to the next line. So you realize that the next hello world line was printed on the same line. So whenever you want to print things on different lines, remember to append /n or end line. Now in the second line, we rather inserted our /n in between hello and world. So when we run the code, you realize that there is a line break. Sorry, let me revert it. So when we run this code, we get or we see a line break between hello and world. And in case you are thinking about this shifting, it is because we have a space after the /n. Now, if you don't want your /n to be in double quote, then equally you can bring another insertion operator, but take note, /n is a character, so you can put it in a character, or you can delimit it by a single quote like this, and it should have the same effect as the former. Okay, so you can see that everything works fine. So if you don't want your escape sequence to be inside the string, then you have to put it in a single quote. But however, if I change this to double quote, it should still work. /t is called the horizontal tab, or tab for short. When used in code, it inserts a sequence of empty spaces at the current cursor position. The number of spaces will depend on the settings you have made on your system. By default, it is 4. Now, its effect is like pressing the tab key on your keyboard. Sometimes you want to print a single quote and a double quote in a string literal. However, when you insert them, they confuse the compiler and it raises an error. Now, to remedy this, you escape the single quote or double quote with a backslash, as we've done here. So we want to say that prof said welcome, but then we want to put this welcome inside single quote. Okay, I want to put this welcome inside a single quote, but I think even for C++, we should be able to print this without the double quote. Yes. So actually scratch that. For single quotes, you can go ahead and insert them inside the string. Okay, but for double quote, you see, because we delimit strings by double quote, the moment I insert this double quote here without the backslash, then C++ is going to take it that the first string begins from here and ends here, and the second begins from here and ends there. So you can see that the color of the welcome has changed. So this is telling you that C++ is actually not recognizing this as a string or as part of the string. Now if I try to run this program right now, we are going to get an error, okay, which says that semicolon expected before welcome, because it is actually not able to make sense of what we've done here. Now let's undo and put back our single quote, our backslashes. Now everything works fine and we're able to get prof said double quote welcome. So remember this, anytime you want to print double quote, because double quote has a special meaning in C++, you have to escape it. Escaping a character tells the compiler that, hey, I know you have a special meaning for this, I know you have a special definition for this character, but I don't want you to interpret it by that definition. Similarly, we are using the backslash to escape other characters. Okay, so how do we also print backslash? Because if you don't take care and you put backslash, it will take whatever character follows as an escape sequence and try to interpret it in that way. Now the way you avoid that is by backslashing the backslash, that is putting a backslash in front of another backslash. Now when we run this code, you realize that we don't get double backslash, but we get one of them. So in effect, putting double backslashes tells C++ that, hey, I need an actual backslash, not your interpreted backslash. C++ also gives us a way to represent octal and hexadecimal numbers. FYI, octal numbers are base 8 numbers and they can contain the digits from 0 up to 7. Hexadecimal numbers are 16 numbers, they can contain the digit 1 up to 15. However, because by default human beings we use the base 10 numeral, our digits ends at 9. So mathematicians had to come up with a new method, a new technique. So in the base 16 representation, we use capital A to represent 10, capital B to represent 11, capital C to represent 12, capital D 13, capital E 14, capital F 15. Okay, so FF in base 16 is equivalent to 255 in base 10. Okay, now to represent octal values in C++, all you have to do is to put a single backslash in front of your base 8 number. To represent base 16, you put slash F, a backslash, and X in front of your base 16 number. Now let's run this code and see what we get. So we have 5 and E. Whoa, what is happening? We're from the 5, we're from the E. Okay, so 65 base 8. What the program is actually doing is that it is recognizing 65 as base 8, alright, but then internally is converting the 65 to base 10 and giving us the character representation of 65. So it is the character representation of 65, that is the character 5. So this 5 here is not the number 5, but it is the character 5, which I think should be, I've forgotten the value, but you can do the calculation, convert this from base 8 to base 10, and then you find the ASCII value or ASCII character corresponding to that particular number that you get. Now over here too, we have 65 base 16. So what the computer is doing is converting this into base 10 and then giving us the ASCII representation of the number it gets. So E here, which happens to be an ASCII character, is as a result of 65 base 16. Again, you can do the calculation yourself. Okay, I don't have the values of head, but hey, you can look, you can find out on the chart, ASCII charts from Google. Now, there is another escape sequence called the carriage return. Now, look at this. If I type hello /r and type word followed by an end line, let me comment this out and then run this program. Oops, we only see word, we don't see hello. Now, what is happening? What is happening is this /r, which is carriage return. Now, if you know what a typewriter is, there was this key on the typewriter that when you press, takes you back to the home page or the home row. Okay, now that is exactly what this /r is doing here. So the computer first prints hello, so we have, it prints HELLO, which is 5 characters. But then when it comes across /r, the information it gets is that, or the command it gets is that it should go back to, it should take the insertion point to the beginning of that particular line, okay, and then print what continues. And because the process of writing is in overwrite mode, it clears hello and replaces it with world. Well, in case you don't believe it, let me add Eric here and run this program one more time. Now, what do you see? You see World Eric. World Eric. That's a funny name. World Eric. And what is happening? So it's printed hello Eric, right? Then /r made it take the current cursor line or cursor position to the beginning of the line, after which it wrote world, but world contains 5 letters, and that 5 letters replaced the hello, leaving the Eric. So that is why we have world Eric. Now, there is another character called the null character, which is nothing but \0. It means empty character, and that is the default character for the character data type. It means no character. Okay, it is called the null character. When you put a sequence of characters together, it is called a string literal. Unlike characters, a string literal is delimited by double quotes. I will talk more about string literals in later episodes. I hope this helps. Thank you for watching. If you are interested in electronics, then check out my Electronics 101 tutorials on this same channel. I am Prof, and this is Tech Foundation Africa.